Today in class we looked at even functions, odd functions, and symmetry in functions. Tonight we're going to look at families of functions and parametric changes. Parametric changes are just how changing the numbers in the equation affects the location and direction of the graph. The families we're going to be looking at are linear, quadratic, cubic, absolute value, square root, rational, greatest integer, and piecewise. In the linear function family, that means they're lines. We have two types. We have a constant function, and a constant function is a horizontal line. And then we have oblique linear functions, which are all the lines that go at a slant, either positive or negative. Notice the vertical line is not included because a vertical line is not a function. The basic parent function for a linear function is y equals 0, not y equals c. The actual parent function would be the line y equals 0, which is the horizontal axis. The parametric function y equals c would be any other horizontal line. Y equals 2 is the graph that you have on your paper. That shows the line y equals 2 parallel to y equals 0, a constant function. The parent function for the oblique side of the linear family is y equals x. Notice that it has points on it, 0, 0, 1, 1, 2, 2, 3, 3, and so on. In parametric form, or the vertex form, you may remember this form from parabolas last year in Algebra 2. We have y equals a times the quantity of bx minus c plus d. Last year, I believe you called it something like y equals a times the quantity of x minus h plus k. It's the same exact thing. I have just changed the variables. The plus or minus determines direction. The A, the B, the C, and the D are going to affect the problems in exactly the same way as they affected our trigonometric functions that we graphed. The next family is the quadratic family. And the quadratic family, the shape is called a parabola. The parent is y equals x squared, which means we have ordered pairs at 0, 0, 1, 1, 2, 4, 3, 9, and so on. I'm off my graph at that point. Negative 1, 1, negative 2, 4, negative 3, 9, and so on. Because when we square a negative, we get a positive. That means this is an even function. It is symmetrical about the y-axis. Notice the only change between the linear function parametric form and the quadratic function parametric form is that we have the quantity of bx minus c squared. The next family is the cubic family, y equals x cubed. It has a point at 0, 0, 1, 1, 2, 8, 3, 27, way out of my range, negative 1, negative 1, negative 2, negative 8, negative 3, negative 27, again way out of my range for my graph. So we get this lovely little cube, kind of John Travolta-ish. All cubic functions will have some similarity to that. Again, the only difference in the parametric form is that instead of squared, the bx minus c portion of the function is cubed. Our next family is the absolute value family. Absolute value makes a shape a V shape. V for value, V for victory. The absolute value of 0 is 0. The absolute value of 1 is 1, 2 is 2, and so on. So on the right side of our graph, we have the line y equals x. On the left side of our graph, when you have the absolute value of negative 1, it's 1. Because remember, absolute value is distance from 0. So negative 1, 1, negative 2, 2, and so on. This side of the equation could be graphed as y equals negative x. This is an example of how you can do an absolute value graph as a piecewise function because it has two sides. The only difference is the sign of the equation. Again, notice that the only difference here is that the bx minus c is in absolute value bars instead of being in a parentheses, not squared, not cubed. The next function is the square root function. The parent function y equals the square root of x. When x is 0, y is 0. When x is 1, y is 1. When x is 4, y is 2. When x is 9, y is 3. So what we get for the basic square root parent function is something that looks a little bit like an eyebrow. Again, notice the only difference in the parametric form. The bx minus c is under the square root. The plus or minus a and the plus d is always the same. Our next family is the rational family, the graph of y equals 1 over x. Now, if we're graphing y equals 1 over x, we have two branches to this function. That's one of the differences in a rational function. It has branches and it has asymptotes. And hopefully you remember from Algebra 2 what an asymptote is. A vertical asymptote is a line that the graph will approach but never cross or intersect because the function is undefined at that point. And a horizontal asymptote is a line that the graph will approach as x gets very large or very small. However, when x is close to 0, anything goes. It can cross over, it can stay above, it can be on the asymptote, it doesn't matter. This function looks a little bit different. It doesn't look quite as similar unless you rewrite it this way. You could write this as y equals plus or minus a times the quantity of 1 over bx minus c plus d. They're both the same thing. However, the first form is what they show in your textbook. The graph of a rational function. First, 1 divided by 1 is 1. Now the question is what happens everywhere else? Well, 1 divided by 2 is a half, 1 divided by 3 is a third, 1 divided by 4 is a fourth, 1 divided by 10 is a tenth. So small we really can't get off, so this half of the graph keeps getting closer and closer to 0. Even when you get out to 1,000,000, 1 divided by 1,000,000th is still a positive number. 1,000,000th, I should say. When you're going back closer to the y-axis, 1 divided by 1/2 is 2, 1 divided by 1/3 is 3, 1 divided by 1/4 is 4, and so on. So what happens here is the line is going to get extremely close to the y-axis, but it will never cross it because 1 divided by 0 does not exist. This is my positive branch. I also will get a negative branch because when I do 1 divided by a negative number, my answer is negative. It looks like the same thing, only it's been reflected over the line y equals negative x. So this would be my negative branch. The last two functions we're going to look at are the greatest integer function and piecewise functions. The greatest integer function is also called a floor function or a step function. I misspelled that. The notation for greatest integer function is this double bracket. And what it means is always round down to the next whole number. So what that means is this. The greatest integer of 1 is 1. The greatest integer of 1.8 is 1 because we're always rounding down. We're never rounding up. As a result, what we end up with is a series of stair steps. The greatest, if you round down to 0, you're at 0. You're going to stay at level 0 because all of those decimals are going to round down until you get to the number 1. And then all of a sudden we're going to jump up here to 1. To show that there's only one value at 1, we put the open hole on the 0 level, and then we start it at 1. And we stay at this level until we get to 2, and then it rounds down to 2. And we stay at this level until we get to 3, and then it rounds down to 3, and so on. So we get this lovely little series of stair steps that all have a solid dot on the left and an open circle on the right. They all have a step width of 1 and a step height of 1 for the parent function. Now the parametric changes will affect all of that. You can get longer steps, you can get shorter steps, you can get a greater distance between the steps, and if you make it negative, you can make the open circle on the left and the closed circle on the right, and all kinds of good things. The last thing is a piecewise function, which can be any combination of functions with a specific domain. The key is to graph each piece for a specific domain. So let's take a look at one. Let's say we have y equals x plus 2 for x greater than 1, and y equals negative x squared for x less than or equal to negative 1. Basically, all we have to do is graph each piece, and the easiest way to do that is with an XY table. So the first graph I know is a line, and the line has equation x plus 2, and I know that I'm starting at 1. This is my start point. Now I have to decide, is 1 included or not, and should I count up or down? So first off, looking at this symbol, it's just greater than. So that means I'm going to start with an open circle. The value at 1 is not included in the graph, but the value at 1.1 would be. The value at 1.001 would be. So as I graph this, what I have is I'm going to have a line, and I'm going to have an open circle when x is 1. I need to know where my y should be. So I make myself a little XY table. X is x and y is x plus 2. So I'm going to start with my starting point of 1. When x is 1, y is 3. When x is 2, y is 4. When x is 3, y is 5, and so on. I counted up because I was using x greater than 1 for my values. So I start at 1, 3, and I have an open circle. 2, 4, and it's a dot. 3, 5, and it's a dot. Now remember, everything is happening between here is still good. So 1.1 plus 2 is 3.1, and so on. So all of those points are connected. I end up with a straight line that looks like that, has an open circle to start with. Now I need to graph y equals negative x squared. So again, I need to look at my start point, which is negative 1. And this time, because of that little line underneath there, that means less than or equal to. So the value at negative 1 is included. So when I make my XY table, I am going to be sure to include that point. I start at negative 1, but because it's less, I'm going to go down. So negative 1, negative 2, negative 3. When x is negative 1, I'm going to have negative of whatever x squared is. So I've got a negative of negative 1 squared, which is negative 1. When x is negative 2, I have a negative of whatever negative 2 squared is. So I get negative 4. When x is negative 3, I'm going to get a negative of negative 3 squared. So I'm going to get negative 9. So this is what my graph is going to look like. I'm going to start at negative 1, negative 1, negative 2, negative 4, and negative 3, negative 9. So I have negative 1, negative 1, solid dot. Negative 2, negative 4, solid dot. Negative 3, negative 9, solid dot. I know that a parabola is a U-shape, so this is a part of the U-shape. It's a little bit curvy. It's not a straight line. And those are the two pieces of my graph.